to start it with a lowercase letter. So let's say like list to string, right? And remember, you can put some content in here, but of course, if you don't, put the return value, nothing is going to be what I think of as like thrown over the walls of the function. Okay, so here if I just add the word return, then we're pretty good. The same thing really applies for variables. So I wanted to make this point, functions really like create a new, what's called a scope, okay, in Python. So what you might notice, let's say we put greeting here. Now, this is in like the modular scope, meaning that it's available throughout this file. Okay, once I press shift return, it will be available throughout this file. So what that means is, inside the function, I can reference it, right? Declare the variable greeting here, and then reference it here and return that value, right? So now we have hi everyone. However, if we have what's like a sign off, bye. Okay, so here I'm declaring the variable inside the function, and now I try to access it, right? That breaks. Does that make sense? So you can see any variable defined inside the function, right, has this scope, only has the scope of the function. So throughout the function, I can reference this. I can return, declare this variable, assign it to by, return that variable here, and it's all good. However, if I try to reference it outside of the function, that doesn't work. This is done on purpose, right, by Python. The whole point of this is because this way you don't have to keep track of every single variable in your code, right? Not all of them are available to you. It makes you, remember when we are iterating through nested loops, part of the complication is we have 4 different variables sometimes to hold on to in our head. This is reducing that brain space for us. That's really the point. So what this means is you only have, when we're declaring a variable inside the function, what we're saying is you only have to worry about it here, and then you can think about the return value, but otherwise you don't have to worry about it. It's only defined, it's only going to be used in these few lines. So so this can be pretty useful, and it also just is the way Python works. So I wanted to make sure that you all felt pretty clear about that. This has a functional scope. All right. So inside the function is there. The only way you're going to get access to this variable, or that it's going to have any impact really, is if you throw it over the walls of the function, right, with the return value. So you get the string by, but you don't get any reference to the variable itself. All Python knows out here is that it is the return value of the function. This scope still doesn't have any reference to the variables inside. All right. Variables are treated just like, are treated really just like kind of parameters, right? You can reference, same way that you can reference a parameter, you reference a variable here. Yeah, Narapati?
Yeah, so I just want to clarify. So if we have two the same variable with the same name, but one in function scope and one in global scope, let's say if we reference that function in the function, if we reference that variable in function body, it will look for the in
Right.
function scope first, and then it will, if it doesn't exist, it will look for the global scope. Is that how it works?
Yeah, good question, right? So let's think about this. Let's say we have greeting, hi everyone. So basically, Narapati is saying okay, what if we, kind of clobber, or almost clobber, this this global variable or this modular variable here by putting, let's put a greeting here that says bye. What will this be? So now we do list to string, right? This is of course still bye, right? That makes sense. But the question is, what is greeting? Greeting is still hi everyone. If you want to, so Python probably, like most of the time you don't want to, right? You would not want this thing here to affect that over there. Why would that be pretty bad? Because let's say you forget or you just didn't look about what that function does, and then you do, greeting is hi everyone down here, and then you think, okay, well, let me just call this function here. You don't want this thing to now underneath, right, inside the body of the function to affect this guy up here. It's basically what we were talking about with when we're talking about affecting our dictionaries, right, modifying our data, that danger, right? This can be pretty confusing if this actually affected the output here. So, luckily, if I look at greeting, we're still good. There is a way to override this, which is with the word global. I never use this, so I'm not even too certain about this, but this is the way I think it works. I did it wrong. I think I have to do it this way. Global greeting. So now I'm saying, hey, reference this global variable and now reassign it. I think that's how that works. You see, nope, it still didn't work. That's good. There is a way to do it, but it's not recommended. But you use the global variable. Like I said, I'm not familiar with it because there's really it's like a bad practice in my opinion to do it. Yeah, Tyler.
I think the way it works is you have to declare, if you want it to be a global variable, you have to declare global before the greeting outside of the function. If you want to, at least I think that's how I've used it in the past.
The global greeting here.
Yeah.
Maybe, yeah. Yeah, it might work. Let's not do it, but we can explore it later. Just because it's really not a good thing to do anyway. So anything, this has one scope. This is kind of a scope within this module, this variable, and then this guy over here, right, exists throughout the function. Okay, kind of other things. It's really not great to have the same name as it is. Maybe there are certain cases for that, but normally you can avoid it, and you should try to. Any other things? I mean, the other things that we saw about then was just parameters, right, or arguments to a function. So, right, if we have, some sort of, I guess we're saying list to string, let's say, which I don't love, we'll just do something very simple. All right, we'll just do capitalize the greeting, right, and then this will take our greeting. And then finally, what will we do? We'll return greeting dot capitalize. Okay, so the whole point, I just want to show you a very simple example of, okay, we're passing through the argument here. This is the data that we pass through, and then taking that data and return the value. I'm pretty sure you all know this. Cool. One thing to note, when you're writing functions, let's say we didn't start off that way. Let's say we started off with hi.capitalize, where you have code that has literal values, meaning it has the pure data. You can see it in Python because it's either green, like the number 3, right? Or let's maybe give it a better example. Let's say duplicate or copy. We'll call this copy our data, right? And now let's say we start off without any function, without any arguments. It's hi times by 3 or something like that. 0 copy data takes 0 positional arguments. Yeah, let's remove that. And okay, so right, let's say we call this function copy data, or we have this function copy data, and this is how we originally write it, right? And it triplicates it or whatever. So when you're looking to think of how to make this function a little bit more flexible, and you don't always have to, but sometimes there's good use cases for it. what you want to do is look for like the literal values in the function. Okay, so you can tell because like generally it's either a string or an integer slash float. So you can tell just by looking at the colors, like red or green. So in this case, right, we have this red text, and we can just turn that into greeting, right, and now replace it here. So greeting, hi, copy data. Oh, I didn't press shift return here. And now we have the 3 highs. What just happened there, just to show you that error, I modified. I originally had this, then I put greeting here. I didn't press shift return here, which is why when I did, executed the function, it says it takes 0 positional arguments, even though it looks like it takes one of them. So just a gotcha. It's something with working with Jupyter Notebooks. When we get out of Jupyter Notebooks, those types of errors won't occur anymore. So okay. So one thing we did was right, take this text hi, move it into the argument. The other thing we can take is look at this, right? It shows that this is another opportunity for flexibility, right? You're taking what's literal and you can replace with like number of times. Okay. And now we can do hi, 2 times, right? Or hi, 3 times. Okay. So that's like, it's a comment. When you start to see like those literal values in your function, take a look, consider whether it would make sense to abstract it away, right? By turning it into an argument, and then it makes our function more flexible. Make sense? Cool, David.
Do you use any type hints when defining a function by any chance?
You can. They're not enforced in Python.
Yeah, not like in Java, but like for documentation purposes. Like,
yeah, exactly.
Finding the type.
Right. So for documentation purposes, this is like a new feature, a relatively new feature of Python. So I'm not. I think you can do. It's like. Is it like that?
Yes.
Yeah. So this actually, I do like this. Where what you're doing is you're specifying, right? This doesn't have, it doesn't have a literal impact on, let's take a look at this. So here, right, this data type is supposed to be a string, and this data type is supposed to be an integer, right? So now we'll pass through copy data. We'll do copy data again down here, right? We'll pass through this. Now, what we're trying to specify here is what data type each argument should be, okay? Now, I don't believe, right, this doesn't actually have an impact, right? I can do 3 times 3, and it does 9. However, it is, I think, it is a good thing because, yes, it's good for documentation. Also, I think it's very good for thinking through writing the function. Right? When writing a function, it's really nice to think about what are the inputs say I give you this problem of, make sure that, given text and an integer, duplicate or triplicate, right, the output. So it's very good then to think about, okay, given this input, what are my inputs? My inputs are a string and an integer. Now, how do I then produce the output? Okay, so for those reasons, both for documentation and then also for, I think, like problem solving, yeah, I do think it's a nice thing to do, right? The other thing, how does it, is you specify the return value. Again, it's just not, when this was introduced, is it like this?
Yeah, it's the hyphen and right caret between the closing parentheses and the colon.
Oh, right here.
I think so.
Let's take a look. Define types in Python function. No,
it should be between the colon and the closing parentheses. So hyphen and then the right caret.
Hyphen.
So you put arrow between the parentheses and the semicolon.
So the right parentheses by right there, right the hyphen, and then.
No, you go to space first and then arrow, hyphen first, like the arrow. No, like there you go.
Type it.
Just one.
Just one.
And then string. Yeah. So this is nice too, right? So it's basically like defining the signature to the function, right? So which is like I said, I think this is good, like a good practice to do. We can start doing that, and honestly, I'll try to start doing that because I do think it's a nice thing to do. Like I said, it doesn't have an impact on Python, but I prefer it. Even though you can see I'm not familiar with it, I do think it's a nice thing to start doing. So we can do return, greeting times by the number of times. And now we have both the argument defined, the types of the arguments defined, as well as the output. Cool. Cool, thanks, David. All right, so what do we cover? Well, the main thing I think was like functional scope. All right, so for that, just remember that when we define the variable outside of the function, it has modular scope. Inside of the function, right, it takes on the scope of the function. So this variable, it's defined inside the function. It's also only available inside the function. In order to get access to it, we need to basically return it. Okay, and of course you can return like variations of it as if you capitalize. Okay. This variable, because it's defined outside the function, is available to us inside of the function, right? As well as outside of the function, right, out here. So those are the main things. And just remember, that's done for us, right? It's done to basically reduce our headspace primarily, so that we only have to worry about these variables inside of the function, right? You don't have to worry about them throughout your entire file. Okay. Here's what's next for us. We'll do, I think you might have seen this album, the Spotify Lab. Let's move on from there. We'll move on to this Albums Lab. So the Albums Lab will give you an opportunity to work with the top 500 albums according to Rolling Stones. We'll write these functions, right? Define various arguments. Then from there, there's another data set. There's kind of these additional data sets that you'll work with, where you'll need to, not only work with albums, but also work with songs and somehow relate songs with albums. Okay? So this is what I'll pair you all up to work on. Okay, that seems like it's working. Cool. Okay, so for the first set of problems, right, we'll download the data set. It's always a good idea, of course, to look at the data. So again, you identify it by looking at the edges lots of times. So this is a list of dictionaries, all right, and then the length of the albums, just to see how many there are. You could do some like other initial data exploration, for example, like just confirm that these are unique, right? If this is data regarding the top 500 albums, just check the data set potentially, right? And it's not too hard to do that, I don't think. You would just, go through for album in albums, maybe just check the album name, or actually it's called album. And then, after getting this list of names, then perhaps do a set and then see the length of the set, right? Because the set will unique them. And then from there, and look, there actually are some repeats. So that might be interesting. I don't know, that's a surprise to me. So this would be, so it is a good idea, right? Just to check the data beforehand. And it could be the case that two artists have the same album, that is possible. I'm not quite sure. Or maybe there's a re-release of the same album, in which case perhaps we want to remove that. And now let's, like I said, we don't have to go through all these, but just a couple things to point out. When you're doing these problems, essentially there's two types of problems that we're working through lots of times. One is mapping, and the other one is filtering. So by mapping, what I mean is we start with, say, last time we're starting with a list of dictionaries, and if we're returning a list of the same length, right? So for each element, we're returning, some sort of corresponding value. That I would define as like a mapping problem. So if for each element, and this is like the key word, let's say for every single item in the list, we are returning a corresponding, let's say like coerced value, right? Then we are mapping. For filtering, we are returning a subset, We are not returning every single item in the list. In other words, the output length will change, will be different potentially than my input length. And we are returning a subset of elements from the list, okay? And this is pretty useful to just kind of identify off the bat, because then the logic follows from there, right? If this is a mapping problem, we're going to really need an if statement, right? Because we're always returning each item. If it's a filtering problem, then we will, right? So just like taking a moment to identify this is going to be really useful. And then going along with that, so let's say we now try to do this all albums, right? This is where that suggestion of specifying the data type, right, of the arguments and of the output, I think is very useful. So let's at least experiment. I would say really try to do it. So let's see if we can do it. So we have all albums, and then takes an argument of albums, and this is a list, right? And the way that we have that hint is albums, right, plural. And it's really, even to be more specific, it's a list of dictionaries. I think we can do that, right? So what I'm doing here is, like if I had this visually in my mind, right, it's, okay, so if I had this visually in my mind, it looks something like this, right, list of dictionaries. And now this is indicating the same thing. So it's a list where each element of the list is a dictionary. And the reason why that becomes useful is because, we go to a list again, but where each element of the list actually is a string. Okay? So this now is essentially defining, like already, at least in my brain, this has structured the problem pretty well for me. Go from a list of dictionaries to a list of strings. How do we do that? For album in albums, right? Start with my input for each, and you can read this as for each. Just put the word each in here. For each album in the list of albums, where each album is a dictionary, right? I need to return the string. So I can just do album square bracket. I think it's the album is the name of the key. And then what am I returning, right? A list of strings. So that seems pretty good. And this looks pretty good to me. So once you kind of define these data types, and like I said, you can do this, even define like the nesting part, list of dictionaries. And it's just list, square brackets, dictionary, to list of strings. And it looks already kind of like a mapping problem. So now all artists, right, is the same. Well, it's pretty cool, I saw some groups do, is say, we have this all albums here, and we have this all artists. Let's just make this a little, all artists right here. And so this starts with albums, and now it still is going to end with a list of strings. And really what we're doing is probably just returning the artist name here. And that's pretty good. So there's a lot of similarity, right, between these two functions. And remember, we also gave that hint of well, like, look at the literal, right? Look at like the red and green, essentially, right? Look at the literal code. So what you might think about doing is maybe create a function called, def all by key, or something like that, where you provide in the list of albums, list of dictionaries. It's going to return a list of strings, and then also maybe the, let's just call the attribute, right? Where the attribute is a string, right? And now we can say, okay, from this we'll return whatever key you provide here. And this might be nice. So it'll be all by key, albums, the attribute, and where the attribute is now, let's say, artist, I breaks. Let's see, key is not defined, because this should be attribute. Okay, so now think about what happens. We call all by key, albums, we pass through our list of dictionaries, we pass through the string, and now for every dictionary in the list, we are retrieving that attribute, whatever it is. And if you want now, you can kind of move that in here. Right, so all artists is just all by key. We're providing artists. Let's just make sure that works. Just do that right here. Right, so this is hard-coded, but it's like we're not repeating our logic, things like that. And then same thing, all albums, we'll just basically copy this and pass through album. Yeah, looks good. And this is not, like, you don't have to do this, but it can help, I think, if it works. Oh, because I don't need to provide a second argument, right? Because this is hard-coded here. Yeah. Right. As your code base gets bigger, right, reducing this repetition is useful. Generally, it's nice, like, after every, 5 minutes or so, just, look for the one thing to do is what's called, red, green, refactor. And by this, what we mean is, everything starts off broken in the world, or in code. But then, you just want to get it working. And you do not have to, so the point is, don't worry about the cleanest thing in the world always, especially when you're starting out. Just get it working. But then after you get it working, take a moment and just look over it and think, can you refactor it? So this is essentially what I did here, right? I just got it working, and then it was like, okay, we have this, can we refactor it? And when you refactor it, by refactoring we mean, improve the readability / perform, but really for us now it's readability of the code without changing behavior. So notice we're getting exactly the same output that we started with. The output's not improving, just maybe, we can argue the code is improving. Okay. So it's you can do red, green, and then refactor. And this is the key thing. Actually my first or second day as a developer, I was like I said, we always pair programmed, and I was saying, well, why are we doing it this complicated way? Can we clean this up? He's like, well, you've heard of red, green refactor, right? It's make the mess first. It's hard enough to get something working in coding. So just make the mess, it's fine, get it working. And then after that, you can try to refactor it. It's like writing too. Sometimes it's hard enough to get some words on the page. So just spit it, just get it out there. Be thoughtful about it, but just write some stuff down, and then you can always improve it. Cool. All right, so find by ranks. Yeah, we can talk, same thing here, right? These seem similar actually to me. So find by ranks, if you look at the albums, okay, right, it doesn't, this did throw some people off. I get it, it was a little confusing. This is the number, right, is really what we mean. And you just provide, if you provide a begin rank and an end rank, and let's say begin rank is an integer and end rank is also an integer. And maybe it's an integer, maybe it's a float. We'll change this potentially. And then what does it return to me? It returns a list of dictionaries, I think. Right? Because it's a list of the matching albums. And now we can do something where we say, okay, for album. Oh, and I probably should provide the list of albums here. I don't remember what the instructions give you. But for album, in albums, return the album if the album number is less than the begin rank. This always confuses me. If the begin rank, let's say the begin rank is 1, and then the album number is 3, so we want to return it if the album number is greater than the begin rank. We can say greater than or equal to the begin rank, and the album number is less than or equal to the end rank. And I know we have that default argument stuff, but just get it work. It's like another trick is just get one part solved and then build upon it. Can I do this? Yeah. This might be a little easier to see. And then return this. So the album's begin rank, let's say, is like 2, and then the end rank is 4. And let's return this whole list. So this is actually working. Let's take a look at that again. So we go through each album in the list of albums. If the album number is greater than or equal to the begin rank, meaning it's like 2, 3, or 4 in this example, etc., and the album number is less than or equal to the end rank, then what do I want to return? That whole album. Okay, return the whole dictionary. So we could, essentially, for the find by years, it's kind of the same thing. I guess you see, can we refactor this and do something like def find by? I'll actually leave this for you all as a challenge, I think. Find by, bounds, right? The upper bound or lower bound. And again, what would it take? It takes the list of albums, upper bound, lower bound, right? And the attribute. Okay? And then what do? It's like look for the colors to try to, it almost writes itself, doesn't it? And then also, of course, let's specify this. So this is a list of dictionaries. This is a string. This is an int, or perhaps potentially a float. And then this is also an int. The reason why I'm debating whether or not this should be an int or a float, let's start to fill in the rest of this, is, okay, so we have this working so that we call find by albums, and it goes from 2 to 4. And that looks pretty good. And now that we have that part working, the next component is if you don't provide, and how am I going to do both? I don't think you can both do it. If you don't provide it, right, then it should return all the elements as the lower bound, basically starting from the beginning. And if you don't provide the end rank, it should return everything to the end. So here we can provide begin rank equals, you could do like 1, and end rank equals. And here what you typically do, some people did this, like the length of the list, which is okay. What I would probably do is just do float infinity. right? Just in here, kind of making it clear of, right, just, you know, return everything that like set an upper bound that won't be reached so that you're always less than it, right? And you can do the same thing down here too, where you do float of negative infinity as the lower bound. Let's just see if this works. So now, if we put this, you know, let's do like, I forget how many there are, 450. So now if we put in this number 450, right, it starts there and it keeps going. The question might be, well, how do we, it's using the end rank as float infinity, right? So how would we just specify an end rank without specifying a beginning rank, you know? Well, one thing to note that you can always do in Python is you can always provide the keyword arguments when you're executing it. So you can do begin rank equals. Like I'm saying, this value 450 should point to this variable, okay? And I can also say, okay, this value of end rank should point to, let's say, like 452, right? And now we just have that. In the same way goes, by default, Python will assume that the first, you're specifying, filling in the first two, and the last one's not there, but we can say end rank equals, let's say, like 4, right? And now we are filled in albums, we have filled in end rank, and the one that's missing is begin rank, okay? Also note that if you're using the keyword arguments, the order doesn't matter. So here I'm saying albums equals the list of dictionaries, the albums. And so I can, if I want, I think I can alter this. Not that you would want to, but just to point out that Python will understand that. David, did you have a question? I saw the hand raised for a second.
Oh, you answered it.
Yeah? Okay. Cool. So this was how we could get this to work, right? If we don't provide this, it will take this behavior, right? If you do not provide an argument, right? If it's something where like the argument can be there or not be there and it will still work, right? I think the only way to do that is with the default argument. Okay. Right? Because otherwise you're going to get an argument mismatch error, right? If I just don't define this and then what did I mess up? Look at this argument. This is interesting. Okay. This says non-default argument follows a default argument. Okay? So what this is saying is here I have a non-default argument that's following a default argument. So in Python, you can only, if you have a default argument here, you must have one all the rest of the arguments. Okay? So this will work. I guess I can not have one at begin rank and then put one at end rank. I have two equal signs. That does work fine. That works fine. But if I put something here and then I don't put it in any of the ones going forward, Python will break. All right. So I just want to go through that error message. All right. Cool. So we have albums. We have begin rank. Well, here we'll do float equals negative infinity for a lower bound. And then we'll do infinity for the upper bound. And notice we're being pretty good about defining each of my inputs and making sure I define my outputs as well. Cool. All right. Yeah, Conwell.
Yeah. Could you please go back to the comparison method where you were comparing the, okay, there it is. So this makes total sense to me. We having default values for bacon, dragon, and rec. We did follow somewhat different approach that was assigning them to none. And in the if condition, we checking if it is none, we don't check the condition. If it is non-none, then only we check the condition. I understand this is a better solution, but I wonder if we put it as none, we make it more generic in a way that, for example, the rank is not in numbers, indeed a character like A, B, C, or something. And in that case, will this solution still work?
I see. So that's a good question. It's like, do we want this to, so basically what we're doing here is we're getting around type, like we're purposely making this non-typed. You know what I mean? If we put this as none and this as none, it seems like what we're saying is, well, this will make this non-typed and thus more generic. And I guess the question is just like, is that beneficial? You know, for here, I don't think so. In the case how we're using it in our use cases for right now, right? I don't think it's necessary because both of these are floats or you know are numeric, right? So for this case, I wouldn't do that, and that's kind of like it's a tough thing because the intentions make sense, right? It's like, well, we're refactoring the code, we're making it more generic, but you really only want to do this for the problem, you know, for the current problems. There's another part of engineering, and one consultant I work with said like this is the most important concept in engineering like ever, and it's called "you ain't gonna need it." So it's basically the thing is, well, in the future, like this is all going to happen, and the truth is, like if you're you know, you really just want to solve the problem in front of you, or like you know today. I mean, it's okay if it's planned out for a week from now, but if it's more than that, if it's really just like kind of, I think we're going to need it. The answer is you probably won't. And in the meantime, right, this fits the problem at hand better, right? Cool. All right, so now we can move on to this next section. And right, the thing is here is that we need data related to songs and data that connects albums to songs. So let's just make sure we got everything. So we have this list of albums. And albums, right, is our list of dictionaries. It has an artist, a genre, etc. It does not have anything about songs in them. Then we have songs, and that would be this guy. Let's just only slice one. Okay, then we have songs. Okay, songs, we have this rank. We have a song, we have the artist, we have the year. What we do not have here, so this is our, like, I would actually call this our maybe top songs, or it's okay for now. All right, we'll call this songs. Okay, so we have songs. So the problem is we don't have any attribute of album here. I'd say that's our issue. Okay, our connection between songs and albums exists in this albums tracks thing. Okay, and this is where the problem is. Let's just make sure we understand what the question says. Okay, return the name of the artist and album that has the most songs featured on the top 500 songs lists. Okay, artist and album on the top 500. So that's this guy. So on this top 500 songs list, return the name of the artist. So the artist is easy, right? The album is harder because it doesn't exist here, right? And then the top 10 albums that have this is very similar. The top 10 albums have the most songs featured in the top 10 in the top songs list. So then, so once we get this album thing, we should be good. And I'd say what I saw a lot of people do, and it makes sense. Like you're breaking down the problem, you're translating into code, is you're working with this album tracks thing. But this album tracks thing is a mess. Here's why it's a mess. It's a list of dictionaries where each dictionary then has another list. Like if we were going to describe this, it would be a list. It would be something like this. It would be a list of dictionaries where each dictionary has this tracks key, which is like that's what tracks is. And because of that, then because of this nested structure, this means that we like have to go through nested for loops. So what I propose doing is change the data, right? Meaning you hold on to all the same information, but like the ideal structure of this data would be a list of dictionaries where each track would be something like this. Let's call this I don't know, updated tracks, coerced tracks. That's fine. It's a list of dictionaries where we have keys of like artist, album, and track, right? And you can have track. So if we have that, then I think the problem becomes way easier. Because let's think about what we're asked to do again. What we're asked to do is, once we have this list of tracks, right, where we have the artist and album, then return the name of the artist that has the most song features on the top 500 list. With that, I think we can then go through each of the songs and find the corresponding, go through each of these guys and then find the corresponding artist and album. Something like that. So let's start. I'll start you off there, I suppose. So we said, like, our whole issue basically is that we have this albums tracks thing, and let's start for one. Let's call this my first album track. First album. It's really an album. So we have this first album, and then we can say, okay, for track in first album tracks, right? Let's just print the track for now. Okay, so this is the track. What we really want to have, let's say this, here's my tracks. Because what I really want to do, I think, is we can append this, but it's not going to be perfect. Let's say, we'll start it now, and then we'll wrap this in function. Okay, so this is a good start. What we should do probably is wrap. I don't love all these, global modular variable, whatever, like these variables that exist throughout the file, these global variables. So let's say, given an album, or find tracks from album. We'll write ourselves a function. People call these helper functions. I mean, I don't love that name, but it's what people call these, helper functions. But they're just smaller functions that are little tools, right, that we can then use. And what you always see me doing is, I'm about to write some complicated code. Instead of doing it for everything, just do it for one. And now we can pass through this as an argument and get this working potentially. So we have find tracks from this first album, and just make sure this works, and I need to return it. Okay, so this is a good start. It's not perfect, right? Because we need, we should remove the remix, things like that. So we maybe do like clean track equals track dot, you all know how to do this, dot split on the space hyphen, something like that. And then also only take the clean track, only take this part. So let me solve it, and then I'll break it down. Okay, so now this is a good amount better. We still have this as an issue, I think, right? Right, meaning we should this reprise. You see that coming up, and then these things are repeated. So we should clean this up. But once you have that, let's say we ultimately find this. So this is our tracks for an album. Then what do? We would go through each one of these tracks to create this like dictionary. Track, artist, album. Does that make sense? Right? Because at this point, you have it. Right? We'll start with an album, this first album, and we have the artist, and we have the album name. So we should be able to, for each track, create a dictionary that has, these values in it. Yeah, Miles?
I think that by scrubbing the last half of the tracks, you're going to actually obfuscate like the right answer to some of these, because each of those remixes and remakes are different than the potentially equivalent song on the top 500 list. Like if Strawberry Fields was in the top 500, then you basically have like eliminated potential matches, but also created potential duplicates. So I feel like it's maybe best to leave those be, because if it doesn't match exactly the song in the top 500 list, then it won't match exactly and it won't be relevant.
Yeah, there's a couple things we could do. So I think one thing we could do is scrub them both the same way, right? Like pass them both through the same function. I think, what you could do also is look to see, okay, is there any remix in there, that we want to, like in the top 500 that we want to hold on to? I don't know. I think like I would probably clean my data, like unless, because what I'm trying to do is associate or create a list of associations, and then we could just, between song and the album and artist, this is kind of like my joint. This is the linchpin, connecting these two different types together, right? Album, songs, artists. So we can create that, and then we could clean the top songs. The only issue, like the only kind of issue I would see, is if in that list of top songs, it is like what Strawberry Fields the remix, and then we want to have Strawberry Fields the remix and not just Strawberry Fields. That would be like the only issue. So we could look for it and see if that's the case.
I guess I'm wondering if this is really data cleaning or if it's more like data elimination. Like those records they're not bad records. Mm-hmm. It's just how they were labeled. So it seems like we're not actually cleaning, we're just like eliminating records.
Well, what are we using this for? So we're using this data to link, right? Just as a purpose of linking the song name, right, to the album and things like that. In this case, I think they're right, like this is linked to, the Beatles or whatever. So I don't know. I'm trying to think if there would be any issue, because you're not I don't, unless, like, this is a tool for us to link these records.
Yeah,
on the
but I guess I'm just yeah.
What is it?
On the Rolling Stone Top 500, let's say if a song gets remixed, the initial song that got remixed, it ends up pushing the original song up the ranks. So if you have what's the song name on the list and it gets remixed, if that song ends up being played, the remix version of that song ends up being played, the original song moves up the list in the rank.
Mm-hmm. I mean, it could be like we might have to check it. Yeah, sorry about that. Go ahead.
Yes. So by cleaning it, you're essentially linking all the songs. to each other, because if it's remix, it will move the song up, the original song off the rank.
The problem you're bringing up is really more with the top songs part. You know what I mean? So we can look at that for song in songs, and then basically return the song. Let's see, what is it called? Let me just take a look at this again. Right, because the question is really, are some of these a remix, and then are we going to link them, right? So we can look through each of the song names, right? Each of the song names, and then see for each song dot split on something like, remix, right? Or just see like, does the word remix exist? Song, if remix, and let's do dot lower just to make sure we're not case. If remix in the song, something like that. So it's not in there. It doesn't look like it. Or we can do it on the reprise. Right. So for each one of these songs, so the issue was, or the question was, I guess, okay, are we potentially, like we want to hold on to this word remix if it's in the top, if the top song actually is remix, but when we look at it, actually there, and I think that's a valid thing to check. But here in this case, it's not there. We can. So let's move on from that for now. I think it's like it was a good thing to check. I don't think it's a concern given our data, but we can revisit that. Well, I don't have to. So David's proposing, right? Do both of these, but I don't think I need to because I'm lowering. Right? If I lowercase the song title, then it's always going to be lower here, right? So I think I'm okay. Yeah, so I don't think this is an issue. Either way, all we're doing here is building ourselves a link, basically like almost like a phone book, right? Like saying, if I give you a name, the phone book gives me back a number. Here, it's the same type of thing. We're building this structure where if I give you a track, I'll give you back the artist and the corresponding album, right, associated with it. So that part should always be fine, I think. Even if it could be the case that you want to then look through the list of songs, and let's say it even had something like our top songs had a dictionary that had a name, or I think this is called a song, of Strawberry Fields reprise, right? Or remix, let's say remix. So long as the remix is done by that artist, or like we want to give credit for it, we can match these, right? By splitting on this and then just doing the link. If it's not, right, then I guess then we have a problem. But in this case, we don't have any track that has remix in it, etc. The other thing potentially to do is like remove that data. Are we doing this to map the song to the album? Why can't we use the artist to map? Okay, so we are here connecting the song. We get all of them, right? So I guess the question is, the question asks down below, right, return the name of the artist and album that has the most top songs featured. So we need both of these, and basically just creating the structure here that gives you both the track, the artist, and the album. So I think we're good. Kamal, did you have anything else to clarify with that? I don't know if I fully understood.
No, I'm still not reached that part. So I guess after I try it myself, I'll have a better understanding.
Sure. Okay. So anyway, so with this, what we're doing here basically is like I said, you're basically creating that phone book, or like, when we get to see, it's basically like creating a table that's linking these three structures. And then once you have that, and we have this in a simple, relatively simple format, which is a lot simpler than what we started with of this album's tracks. Once you have that, I think your life becomes a lot easier. Even if you wanted to get rid of this remix part, like say, okay, we're going to remove this data, that's okay. I think this is associating, at least what this data is representing, is associating this remix with this artist, right? So at that point, we can, I think for our purposes, we can combine these, and then if there's a remix value in these top songs, we could just say, okay, according to this, right, that song corresponds to this person. Yeah, I think that's fine. I think it is fair to like question: are we losing some data when we condense information or when we clean stuff? And that's why it is good to hold on to the original. But it's also fair then to coerce the data, right, to solve your problem. And you can always go back to the original to confirm, that, to make sure that you're not losing any data. Cool. I'd say try it this way. Try it, like go through each of the songs, write small functions that just take in a given album or one instance of your data, and then see, okay, now I can work on this, cleaning the data, removing duplicates, and I can create that table. I can create that table, and then from there, you can link these. All right. Cool. Other questions or other concerns about this? That is what we're creating here, this is not the top songs. This is just the link, right, between the two, between albums and the tracks. And so then creating that, that like phone booth, so to speak, that list of dictionaries in a fairly simple, in the data structure that we want, I think that should work. Cool. And this is a typical step, by the way. This is called, pre-processing, or like the way to think about that is pre-process your data. Okay. To put it into the data structure that you want. And try it, see if you get a different answer or if there's any concerns, right? It is fine to also like test your results and make sure you're getting the same output that you would expect. Cool. Does this make sense though, what I'm proposing? Yeah? It's to build this, structure that has, given my album's tracks and having like something like this, where the data is nested, right, to instead transform this into data that's like a list of dictionaries where you have the artist, the Beatles, the album, whatever that album name is, and then the track, one track. Right? And then we go to the next track. And so for this one, it would be With a Little Help from My Friends. Cool. All right. Cool. All right, so let me put you all, feel free to take you can take a 5-minute break or something, and then try to build this structure, right? And this is essentially like your link between the data, and then see how you can use that link between the data to answer the question, right? To then create that counter, etc. All right, so give this a shot. What are each of these variables, and then like what is our overall question? So our overall question generally is, we have this list of top 500 songs, and now the question is return the name of the artist and the album that has the most songs featured in this top 500 list. So again, we have this top 500 list. The problem is we don't have the name of the album, right? That's kind of like our whole problem. And one thing that's going to help us, it seems like, is that we have this albums tracks thing, and that does have the name, the link between the album, the artist, and the song. The problem with this is that it's not formatted very well. So we said in the last section that kind of like maybe what would be really nice is to give in, an album track, given one of these guys that represents album and then the list of tracks, return a list of dictionaries. Okay? So one for each track, right? But this time the track, in that dictionary, we have a track that has the album name and the artist name. So where we left off was we have this album track thing, right? Which this is a dictionary with the keys of artist, album, and the list of tracks. So let's start to label this. And what we want to get back is a list of dictionaries, right? Where it looks like something like this. And I'm just commenting this, right? The artist name, the album name, and the track. So one thing to point out, by the way, is this is kind of a mapping problem, right? Because, once we get to this album tracks thing, we want for every element in this list to get a dictionary, right? Basically, we're going from a string to a dictionary. And the way that we do that is, the attribute doesn't lie on this string, like the artist name, the album name doesn't lie on this string, but it does lie on this guy. So we can, for each track, for each one of these strings in album tracks, right, for each one of these guys, we can, right now we're cleaning it. If you guys didn't want to clean it, that's okay. But what we need to do, I think, is still, let's just print this for now, is still have this be the track name, right, in a dictionary. So we'll call this my track, that's fine. And I'll put in the clean track there. And then here I'll put in the artist. Where does the artist come from? Well, I have it in the album track, right? So I have the artist name. So if I pass through the album track, I can get the artist from the album track artist. And then let's do this again. This time it'll be the album. Okay. And now this is kind of what we want to append. So I'll call this my track. Oh, actually I shouldn't call it that, because if I call it track, now I'm overriding this guy. So let's call this my clean track, or whatever, or full track is even better. And maybe I should have called this my track name, and this maybe it should be track name, but we'll keep it for now. And then we'll append in the full track. Okay. And I'm no longer printing. So now we have a list of dictionaries. So I'd say the main, a couple things to kind of keep in mind here is, okay, what is album track, right? It's a dictionary with keys of, right? It's like just going back to defining the input and output really helps, right? It has keys of the album name, the artist name, right? And then tracks, which is a list. Then we go through each one of them. What is this? This is a list of strings, right? And now once I step inside the for loop, basically what I'm working with is each individual track is a string. So I take the track, I clean it, get the first part of the string, and then I add it to this list. And, it would be nice if I could get the information from the track, but I can't get the artist name from there. I have to go one up like kind of a little bit higher, and get it from this dictionary that has the keys of the artist and the album, and then append that to the list. Okay. For this, this only does this for one single album. We can do this the easier way. I think this is actually easier way is now to go through all the album tracks. We can do it this way. Part of me doesn't like that. I'm not going to do that actually. So we can, let's say we pass through multiple different albums. So we'll do the first album is, right, this is the first album, right? So given this data type, let me just show this again. Given this data type that's a dictionary, that's not in a nice format, it will output it in a nice format, right? This is what we just did. And if we do the second album, let's do this. It will now do this for the Beach Boys, okay? So we can go through this list. The problem is, so what we would normally do is like loop through it. So it's like 4 album track in, right? For each element in this list, 4 album track in albums tracks, right? Find the track, output this kind of list, and maybe append it. And we're going to clean this up because this is okay. But let's say all cleaned track. I don't know what to call it, but that's okay. And let's call this my cleaned tracks, or let's say all full tracks, right? And these are my full tracks. And then for each album track in the list of album tracks, for each one of those weird dictionaries in the list of album tracks, extract the data, right? And this gives me back what? A list of dictionaries. And now append this list of dictionaries to this list. And like I said, we're going to run into a bit of a problem here. So, all full tracks, .append. So the problem that we run into, let's slice this, is this is nested again, and we don't want it to be. Really, the problem is we're appending this guy, right? We're appending a list of dictionaries into another list. So that's why when you do that, it gives you back like a list of these things, one for each album track. All right. There are different ways to handle this. The easiest way that I can think of is actually to try to, instead of appending, to concatenate. So, just to bring this point home, if you take these, right, let's say there's 2 of these, let's say, first tracks. And we have these second tracks. And let's do this, will be album tracks, square bracket, 0. Albums tracks. Okay, so if you look at first tracks and second tracks, so second tracks is Sgt. Pepper's, first tracks is Outkast, right? So now if we try to combine them, right, we have our full tracks, we do full tracks, dot append, the first tracks, and then we do full tracks dot append the second tracks. You'll see that this gives me back a nested I'm lying. Second tracks. How did I actually do that successfully? Full tracks dot append first tracks. Sorry about that. First tracks is a list, right? Yeah, first tracks is a list. Second tracks, I think, is also a list, right? And now we'll do append in the first tracks and the second track. So we should be appending in 2 lists. It could be that I think I know what happened. I think I already had that variable existing. So full tracks dot append. Now we'll try this again. I think what happened was I already had this thing defined, so I'm just going to reset it, and now look at it. So now you see that? This is a mess. We're back to working with nested data. So instead of appending it, what you can do is just add it. It's just what's called concatenating it. So if you do first tracks plus, or full tracks plus, so take this empty list and add to it, right? You see that? It's not nested the same way it is down here. Now the issue is this returns a new list, so you should actually do something like this. So if you look at this, you're like, why is this thing empty? It's because this guy right here returns a new list. It doesn't modify the original, so you'd have to do something like this: full tracks equals full tracks plus first tracks, right? And then full tracks equals full tracks plus second tracks. So now we're back to our loop. Okay, so now instead of appending this guy, the find albums from tracks, we'll do all full tracks plus the full tracks, and we'll say that equals. Okay, and now that should get rid of this nested part, right? And that seems to, and it should actually be for all of our albums. So if we look, let's just get a sense of the length of this, right? And this looks right better. So now we have at least what's close to, if we like look at some of the data, each track, Sgt. Pepper's, this is a different track, this is the next track. I'd also like to look at maybe the end of the data. So let's say -10 to the end. So here's our Outcast material. Again, we have the track, the artist, track artist. So this looks pretty good in terms of the data. So now, remember the whole point of this, we could wrap this in a function. We probably should, build all the tracks, build all tracks. And then return it, all full tracks. It takes for each one of these in albums tracks, so it should take in this as an argument, and then return all full tracks. And then let's just take a look at the return value. These will be my all full tracks. Yeah, and this still looks good. So basically, I'm just wrapping this in a function. Sorry if that was a bit fast, but it's taking our messy data now. So we did it for one, and now we go through each one of those dictionaries that has that crazy list of track names inside. We go through each one of them, and we concatenate it to this list right here, and then we just return the value and we assign it to this variable and then go from here. Now, what can we do? We have our list of songs, okay? So we can say for each song in songs, what would we want to do? We want to get the corresponding album, I think, in fact, maybe what we can do, actually, if you all want to, let's start with each of these song names. We'll create our dictionary. So we'll create like a placeholder and it seems like we will make it, so I'll go a little slower. So we can create a counter, right? Because the whole task, I think, was to have the album with the most top songs. And we have, so the first task is to create a dictionary of all of the albums here, I suppose. All right. So let's say for album or for track in all full tracks, we can pull out the track album, I think. Right, so this is a list of all the albums, and then we just want to set it and turn it back to a list. So, make it unique. And now I hope we should still be good, right? I think this is right, these are albums. So these are my album names. you know. And then from there, what we can do is do something like for album name in album names. We could create, let's just create a counter, a dictionary, and then we can do, you know, counter square bracket album name equals 0, something like that. And now for each of these, so we went through every album name and we said, okay, here's my counter, set a key value pair where the name of the album is the key and the value is 0, right? And then after that, we can probably go back to my songs, my list of top songs, and say, okay, for each song in the list of songs, you know, do a lookup. Basically, get the album. Let's just take a look if this works. So I'll just slice through the first few. Do song, square bracket, and let's maybe say like find song from tracks, you know, like find the song over here. So let's actually bring that into a function. So given a song from song find album. And I think I'll just go like 5 minutes over and I'll probably be good. So from song find album, here we're going to take one of these guys, call this a song, right? And then write a function that basically, what should it do? Go through all full tracks. We could even put that in as an argument name and say, okay, for track in all full tracks, return the track if the track, so it's these guys, if the track, square bracket track, equals the song name, right? Song, square bracket song, and then return. So we'll return a list of the matches ideally. Let's see if this works. So given Bob Dylan, now I have not all this list that also has the album associated with it. Okay? So this is kind of like our match, which is nice. Yeah, that's pretty nice. We only need one, so we could, just to make it a little easier on myself, I'll just do something like, call this my matching songs for full tracks, and then just say, you know, like if matching full tracks, return it. Return the matching full tracks square bracket 0. Like if it exists, return the first element, just to make this like not nested anymore. Okay. So now we kind of have our tools in place, I think, to go through like loop through the data, or at least do a first pass at this. So that would be, you know, again, we have this list of top songs, right? So for each one of these top songs, let's find the song from the album, and we'll call this from song find album. Maybe we should go like find track, and we'll call this my, you know, full track. Okay, and I find full track. Find full track. I'm just renaming it here. Okay, so for each song, from this song, this top song thing, right? Go through each one of these. For each dictionary here, find the full track, and this should return to me this guy, right? With the album name. And then what we want to do is take the album is full track bracket album, the album name. And then what we want to do is do counter of the album name plus or equals 1, something like that, right? For each song in the list, get the corresponding like full track that has the album name in here, get the album name, add 1, and it breaks, of course. None type is not subscriptable. What could be happening is breaking here. So I know what's happening here. In certain cases, this returns none, right? It says if we find a match, return it, but otherwise we're returning none, you know? Does that make sense? So go through all the tracks, see if there's a match. Where there's a match, return it. So now we're breaking because this is none sometimes, and so we're trying to do like none square bracket album. So we can basically just say, put an if block. If there's a full track, right? Only where this thing is present, then get back the album name and find it from the dictionary, increment it. And then from here you can do items potentially, and then sorted, right? This is giving you a list of tuples, right, with the count, and then you can do something like sorted by lambda, let's say like album count, and the album count square bracket 1, something like that. And let's turn this back into a list. Ugh, I broke it. Sorted expected 1 argument got 2. I need to do key equals, right? Key equals, something like that. And we want to do reverse equals true. Did I break this? Oh, it's right here. Reverse equals true. Yeah. Something like that. Sorry I went fast at the end. But the key parts are really just, by the time you get to the end, it's, not so bad. The key things, I think, are, right, we have this logic of given a song, find the matching track, which all that is just a loop looking for where this track matches our song that we're passing through here. And then you just trust the function. Like, what does this do? Well, it returns this dictionary. And now, do this for each of my songs in the top 500, find the matching track that has the album name. If there's a match, pull out the album name, and then add this to the counter. Okay? This is hard, obviously. In fact, like in other classes, it takes them like 3 days, like 8-hour days or something. But I know from you all that you're all quite good. So, okay. So you can see we're downloading some data. This is our movies. And basically, the whole point, and we kind of talked about this already, is, okay, if you have code like this, how do you refactor this into a function? And maybe it already feels, pretty obvious to you, which is, it's like, where are the arguments? So you start by saying, like, maybe find, since year. So maybe choose a good name first. And I would say that, like, part of the confusion, part of what's making your lives hard still is your variable names. And it is still the lowest hanging fruit to make it so much easier to write good code. So you can just begin by, having this find sincere. Like, this is a pretty good variable name, I think. And we notice I'm going through my list of movies, for movie in movies, if the movie year is greater than or equal. It should be called find after year, right? And by now, maybe you can kind of figure out exactly how I'm going to refactor this, right? So we're looking for the colors, okay? So this is, maybe the first one would probably be this, right? Find after movie year, and we'll do year. And then we'll just plug this in with year. Okay, and that's really it. And I broke it because I needed to find year. Okay, so this is everything after 2015, and then same thing, we can just do 2018. Okay. Of course, we said, we can we can change the attribute. You see that I'm doing that here. And then the main point, one thing just to notice is like this is movies where greater than, and then you can see I can pass through, right, like the key of revenue and then some sort of revenue amount. Let me just declare this. One thing just to notice is that there is a trade-off between like it's not like refactoring. You can refactor too much, and the reason why is notice like how more vague this is. If the movie key, like it's a little harder to understand, like movie year, you know. Same thing here. Like look how vague this is, key value, you know, as opposed to the readability of our code up top, which is if the movie year, right? This seems way more like understandable what's going on here. So there's just a trade-off, like the benefit of, you know, this abstraction, meaning like I'm reducing the hard coding, is that it's more flexible. Okay, but the cost is potentially less readable, and another thing is potentially more indirect. Last time it's like more indirect. So another way of thinking about this is like, you know, let's say we have this movies where greater than, and now we use this in our movie since function, right? So previously we had movies since year look like this, and now we're like, well, now we have this movies greater than function that we just wrote, and now we do call the movies greater than, and now we pass through the year, and the value is this year, okay? And we return that. So let's just first confirm that this works. Right, so we're redefining movies since to use this movies greater than. So movies where greater than calls this, and where the key, you know, this specified key is greater than or equal to the value we pass through, we return it. And so we'll do movies since 2016. Okay, so again, this works, right? This is a proper refactoring, right? We haven't changed behavior, but we, you know, arguably made our code more, a little more, clearer, but more reusable, right? Because we're leaning on this movies were greater than function. Again, so downside is this is indirect, a little indirect, right? Because before the code is just right here. This time now we call this function, and now I gotta go look at this guy in order to figure out what's going on. Do you know what I mean? So like, this is the downside of refactoring too much. And this is why, like, you know, people get paid to do this, right? Because it's a craft and it's a balance, right? And it's, you know, that's what this is. So there are trade-offs, and the trade-offs are just like why you have to think as an engineer, you know, and it's something you'll pick up on over time, but it's also something for you to pay attention to, of like, why is this code hard to work with? You know, okay, well, it's actually like pretty hard to read, or maybe, you know, this thing takes me over here, right? And, you know, there are, like I said, there are pluses to this and minuses to it, and you just want to be aware of it and then weigh the cost benefit. Like, do I save a lot by making this more flexible, or does this thing start to weigh on me that it's more indirect? Okay. One thing I will say, so one thing I saw you all do, or some groups do, which I think is actually okay, is they're like, all right, well, you know, if I'm solving this problem, of like, say we find all the movies, you know, after the year, well, I'm just going to hard code it at first and make sure this works, and that's fine. Like, I think that's totally valid to do that. Just get it working. But then what I say is, once you get it working, like, check it off. Like, make it okay, right? We talked about kind of like red-green refactor, right? But then refactor. And the easy step of refactor is simply wrap it in a function. You know, wrap it in a function so that we have like movies after this, you know, after this year, pass through the year, and then, you know, return it. And now what I've done is I've removed, oh, and let's also have movies. I'm not introducing any new variables into my global scope because everything's inside this function. I'm specifying what's the inputs, what's the outputs, and so I've made my code more easy to read for when I, shift my attention someplace else, right? Now that I'm going to move on to the next problem, and I can always go back to this, and it's just easier to read an hour later, half an hour later, whatever, a year later, right? So that's what I'd say is like, it's totally fine to, I just want to get a few lines working. I don't want to worry about, writing this in a function right now or making this that's fine. But then after you get it working, wrap it in a function, feel like, all right, we're done with that. Like we cleaned it up a little bit, move on to the next chore, the next task. Okay. Okay. So we have like 12 minutes left. You can go through this reading, and then there is, I think, some challenges. Oh, here we go. We wrote code to select the top 100 movies by revenue. So write a method called top that returns the top 100 movies by any category. Limits to the top 100 by default, but allows for specifying any limit. Has an argument descending that is default equals true, sort from top to bottom. Let me actually go through this sorted method. Sorry that this is a little longer than I expected. So here we have our list of movies. This sorted method has to take a list, or like a list like, if it's a list of tuples, but it has to take a list, right? So if we have a list of numbers, 1, 10, 2, 3, and we do sorted, obviously, right, it returns them in sorted order. The issue is when you have a list of dictionaries, right, like movies, the question is, well, okay, if I'm going to sort the elements in this list, what attribute are you talking about? Like, should I sort it to put them in alphabetical order, or should I sort them to put it like in terms of budget, right? So the way sorted works is you can, as the first argument, you still pass through your list. That's this thing. And then it's like saying when you do this key equals, this is a keyword argument, right? So the word that, we have def sorted, you pass through your iterable, you can imagine, and then we have a key where the key is saying where you pass through, all right, what do you want me to sort by? So here you do what's called like a lambda function, where you do lambda, and now this is each element in the list, all right? So lambda movie, okay? And now what do you want to sort by? Let's sort by movie runtime. Let me show you how this works. So you can see, let's just do the first few. So we should see some pretty short movies here. Runtime is actually like, 0, which is a lie, 63 and 72. So a way to think about this is like a lambda function. A way to think about this is that it's just an unnamed function, right? So what do I mean by that? If we were going to define a function, let's say movie attribute, okay? And what does it take as an argument? Movie. And what are we going to return from it? Let's say the movie runtime. Takes a movie maybe and also the attribute itself. Okay? And actually we'll call it movie runtime. Okay. Okay, so this is a function called movie runtime. Provided a movie, it returns the runtime. Okay? What we're doing here is we're saying this is only for this, one-time use. Like this snippet of code is like only going to be used here, so I don't even need to name it. So in other words, let's like skip all the formality of giving this thing a name and just remove this part. So I'll copy this down here and show you how we get there. So let's remove this part. So we'll get rid of this because we don't need the formality, and we'll get rid of this parentheses thing, and then we'll get rid of this return thing. Okay? And now this still is returning the movie runtime. If you have a lambda function, this is still used to return the movie runtime. So that's what's going on right here, is we're saying, okay, for each element in this list, right, I'm going to call this thing movie. This is my argument, right, that you're passing through. And then I'm going to extract this piece of data. And so now we're going to sort based on the return value right here for each element in the list. Okay. So that's what's going on there. How does this feel to you all? Okay, so this is the argument, and you're basically naming each element. You're saying, what do I call, how do I refer to each element in this list? Let's refer to it as movie, and then I want you to sort by the return value of this. Okay, so you can call this whatever you want, right? It's still going to reference it's still the name that you're giving each element in the list, the same way that, I can call this argument whatever I want, right? It doesn't really matter. And whatever I pass through, this is just what I should refer to it as. Yeah, does it feel okay? All right, let me deploy this reading, I suppose. We got a few minutes left. And then that will probably be good. So we'll just do this refactor reading. We'll leave the challenge, I guess, for next class. I'll deploy that.